So I want to graph this right here. I'm going to use a table to graph it, and I have to choose good values in order to graph it. In order to graph and find good values, you want this inside of here to equal 1 and the base. So that's the best way to graph it. So I want x minus 3 to equal 1. I also want x minus 3 to equal the base, and for this log, the base is 4. Now some of you can just look at that and see it. But I'm going to solve it in case you can't just see it on your own. So that would be 4. So my first value I'm going to plug in is 4. And here I'm going to add 3 over, and I get 7. So the second number I'm going to plug in is 7. Those two numbers will give us nice, clean outputs that will give us nice dots for graphing. You choose other values, you have to deal with decimals and approximations, and it could be a pain. So let's plug it in. I have negative 2 times log base 4, and when I plug in 4 right here, what's 4 minus 3? 4 minus 3 is 1. So this is going to be a 1 in here, and then you have the plus 1 at the end. So again, I rewrote 2, and I plugged in 4, got 1. Now, what does this equal? Well, I have to pause for a second and think, what does this log equal? So I have to pause for a second. What does that equal? Well, hopefully you can understand by now that that is really saying 5 to what power is 1? 4 to what power is 1? Thank you. 4 to what power is 1, and hopefully you can see that's 0. So hopefully you can see that this right here, it's 4 to the 0 is 1, so I replace that log with 0. Now, negative 2 times 0 is 0. 0 plus 1 is 1. So my coordinate, I'm going to go over here and graph, is 4, 1. I'm going to plot 4, 1. That's a dot. Now, let's plug in 7. So, log base 4 plus 1. When I plug in 7, 7 minus 3 is 4, so I'm going to put 4 right there. And 4 to the what power equals 4 is what this is saying. 4 to the what power is 4. That's what log 4 base 4 is. And that would be 1. So this is negative 2 times 1 plus 1. Again, this piece right here equals 1. Because 4 to the first equals 4. Negative 2 times 1 is negative 2. Negative 2 plus 1 is negative 1. So I go make a coordinate at 7, negative 1. There's my second dot. Now, I also know I have a vertical asymptote, which is the next question. Since it's a vertical asymptote, it's going to be x equals, and it's always x equals h, and my h is positive 3. So I'm going to go and draw a vertical asymptote here at x equals positive 3. Now, just for your note purposes, you might want to write x equals h. Your asymptote is always x equals h. It's always the h value. You might want to write that down. It's up to you. But that's where I got the 3 from, the h value. Now, I got to decide, is my graph going to go like this and come back down? Or is it going to go like this? And hopefully you can think of a logarithm kind of look like a square root graph. Since it's negative, it's kind of like upside down square root graph look. So hopefully you can piece this together and understand it's going to look something like, oops, I got to hit that, missed that a little bit. Something like that. Something like that. Going through the 2 dots and up against the asymptote. Next question. What is the domain? Well, is there any graph left of 3? No, it's just a whole bunch of empty space. So my domain says there's no graph there. So what my domain is going to be is everything from 3 to infinity, or right of 3, which is also written as greater than 3. So my domain are any x values right of 3. And those are the 2 different ways of writing that. So now I want to know, when is f of x, which is the green graph, equal to negative 1? So let's graph negative 1. So if I graph negative 1, that would be a graph right there. So this graph right here is y equals negative 1. So aren't they equal right there? Isn't that where the two graphs, where y equals negative 1 and the green graph cross? And what is the x value there? It's x equals 7. So my answer here is x equals 7 is where the graph of negative 1 and f of x, right here, which is the red green graph. Last question is find f of 19. So let's plug 19 into this. That's all it's saying. So to plug it in, we got negative 2 times log base 4 plus 3. Now, when I plug 19 right here, what's 19 minus 3? 16. So what I'm going to have here is this is actually going to be 16 once I plug it in. All right. So what does this part of the equation equal? 4 to the what power 16? Hopefully you can see that is 2. So this is negative 2 times something plus 3. And what did we say that equals? We just said that equals 2. So now, what do you get when you multiply those? That's negative 4 plus 3. So my answer is negative 1. And if we think about it, okay, if we go and, oh, I messed up. No one noticed it. What did I do wrong? Something, I noticed something went wrong here, and that's okay, because watch this. 19 negative 1. That means I go 19 negative, wait, I've already got negative 1. 19, that wouldn't make sense of the graph. The graph would be going back up. And what I just noticed is that's not negative 3. That's not a positive 3, it's positive 1. So let me go back and fix that. Isn't this going to be a positive 1, positive 1? Which means, isn't that 1? Isn't that a 1? So won't that change this too? So, and I got to change this too. So won't this equal 1 here? Won't this be negative 3? Which, does that make more sense? If I have 19 negative 3, if I went over 19, which is way off the graph, would I possibly be down here at negative 3? Yeah. It was kind of cool. I like making that mistake because I checked myself, because I saw negative 1. That doesn't make any sense. How could a negative 1 happen if I already have negative 1? It'd have to come back up, or it'd have to do something weird. So what's awesome is I actually checked myself before I wrecked myself completely.